So we've talked a lot about cholesterol metabolism as it's integral to the cell. And there's a couple last pieces I want you to appreciate before we finish this week. The first is asking the question, how do we get rid of excess cholesterol from the body? And we do this through bile acids. Only a small percentage of bile acid is secreted in the feces. You'll notice that the majority of bile acid produced and used in the digestive process is recirculated back to the liver through enterohepatic circulation. The second take-home message I want you to appreciate is that cholesterol, although we use it as an end product, is really the starting product for the synthesis of a lot of other compounds. It's a starting product for the synthesis of bile acids, for one, and also for all of our steroid hormones, as well as cortisol that we've talked about throughout the course. So briefly, with respect to the synthesis of bile acids, this occurs in the liver with, again, cholesterol as our starting substrate. The initial reaction and the regulated reaction is by 7-alpha hydroxylase, which can be inhibited by its product, bile acids, and requires vitamin C as well as NADPH. You'll also notice that cholesterol allosterically activates this enzyme. So again, as intracellular pools of cholesterol elevate, this will increase the production of bile acids. So we initially produce these primary bile acids, and those are primarily cholic acid and chenodeoxycholic acid. And before they're released into the intestine, they're conjugated, and that's either with a taurine or glycine. So these primary bile acids are highly soluble and are part of the digestive process to emulsify fats and lipids. Through interactions with gut bacteria, they are metabolized to secondary bile acids. So lithocholic acid, this secondary bile acid, is not very soluble, and so the majority of cholesterol is secreted in the feces in this secondary metabolite form. The remaining bile acids are recirculated back to the liver through the enterohepatic circulation. So this really summarizes the role of cholesterol and cholesterol metabolism and transport. So let's finish with this clinically relevant question. So cholesterol-lowering drugs include statins, which we know inhibit HMG-CoA reductase, our regulatory enzyme for cholesterol synthesis. And we also have bile acid sequestrants. So what is the rationale for using this combined therapy for the management of hyperlipidemia? So first of all, we know that the only real means of excreting excess cholesterol is through bile acids. And we also know that bile acid synthesis is inhibited by bile acid. So these bile acid sequestrants sequester bile acids in the intestine and increase the amount secreted in the feces. And by doing that, that reduces the amount that's recycled back to the liver and thereby increases bile acid synthesis. We also know that by inhibiting HMG-CoA reductase through statins, this will reduce de novo synthesis of intracellular cholesterol. And as the pool of intracellular cholesterol decreases, we can get an increase in uptake of the LDL particles. And both of these are key roles of reducing plasma cholesterol. So if we look at that here, the bile acid sequestrants first will increase our amount of bile acids we can excrete in the feces. This reduces the amount of bile acid returned to the liver, and therefore we can increase our de novo synthesis of bile acids. This will decrease our intracellular pool of cholesterol and increase LDL uptake. We can also decrease intracellular cholesterol by inhibiting the HMG-CoA reductase. And as this pool decreases further, we will again increase uptake by LDL. So the enhanced uptake of LDL is our real major contributor to reducing plasma cholesterol in this case. All right, that's it for week 12 and for unit 3.